Well, Luke, now that you've been driving around in that car for a while, what do you think of our new constant control, full-time power steering?
Boy, it handles like a dream, Keith. Just like you said it would. It's got a nice feel of the road, and everything seems to be under full control all the time. Our customers are sure going to go for it.
You're so right, Luke. Your first impression when you look at the unit is that it appears smaller. It is more compact, all right, and it does have fewer parts. And notice this. Look how easy it is to reach the cross-shaft adjusting screw and lock nut. Makes adjusting backlash a lot easier.
It sure does, Tech.
And that's not the only handy location, Luke. The steering control valve body is mounted on top of the gear housing. The back pressure valve housing is attached to the end of the steering control valve body.
That location of the steering valve body provides a new adjusting feature. You can shift that position to adjust for equal assist on left and right turns.
Right. Service has been simplified, and we'll cover it as soon as we get you better acquainted with the new parts. The sector shaft is mounted vertically in the one-piece housing and operates on roller bearings. There's one set of roller bearings at the upper end and two sets below the sector teeth. A spanner nut secures a cover holding the sector shaft in the housing. The sector shaft adjusting screw threads through a seal in the cover. A second seal between the cover and housing guards against leakage.
How about the seal at the other end?
There's a seal and a retainer installed at the lower end of the sector shaft. They're held in by a snap ring. The shaft and its bearings, remember, are pressure lubricated, so good seals are vital. Now, let's talk about the worm shaft for a moment. It connects the steering wheel to the power unit piston through a flexible coupling. Two recirculating ball circuits gear the worm shaft to the piston.
The worm shaft and piston are serviced only as an assembly. Those ball bearings in the recirculating circuits are precision made to a gnat's eyebrow.
Tech's right, Luke. Those balls are selectively fitted by electronic equipment, so there will be an absolute minimum of friction and free play.
Oh, no wonder the worm shaft and piston are serviced together.
That's the idea. It's pretty hard to beat those electronic gauges. You'll notice that the worm shaft extends through a cylinder head and through the column support at the upper end of the gear housing. A spanner nut holds the column support to the housing. A roller bearing supports the upper end of the worm shaft in the column support. There is a low friction seal between the main shaft and cylinder head that is a little different. You'll notice the shaft journal is fitted with a cast iron seal ring. It seats in a self-aligning sleeve held in the cylinder head by a snap ring. A seal is located behind the sleeve.
What's that cast iron seal ring for?
It prevents excessive leakage around the worm shaft, which would result in reduced pressure in the left turn pressure chamber.
Okay, Keith, I get it. Keep it going.
All right, now suppose you cut away the spacer that's sandwiched between the cylinder head and column support. That'd give you an inside look at the reaction area parts. You'd soon see that the spacer, which is clamped between the cylinder head and column support, can't move. The center race, on the other hand, can move.
Think of that center race as being a part of a thrust bearing. The thrust bearing has two outer races, two sets of roller bearings, the center race, and a lock nut holding the entire assembly on the worm shaft.
Looks to me like that thrust bearing would permit a slight endwise movement of the worm shaft.
It does, Luke. That slight movement means that the center race also moves.
Movement of the center race is used to control the movement of the steering valve. You see, the lower end of the steering valve pivot lever has a spherical bearing surface that rides in and moves with the center race. Just above that is another spherical bearing surface which pivots in the stationary spacer. Still another spherical bearing surface at the upper end of the lever fits into the steering valve.
I think I'm beginning to see the light, Keith. But what keeps that center race lined up with the spacer?
2 reaction rings. These rings bear against the center race and spacer and are mechanically loaded by 2 washer-type springs. Besides that, there's hydraulic force to consider. Suppose we take a look at how the hydraulic area behaves during a left and then a right turn. That should clear up some of the clouds.
Okay by me, Keith. Fire away.
Well, as you see it here, the spool-type steering valve is in neutral position. And in neutral, it straddles the 2 ports in the valve body. Therefore, both ports are partially open. The lower port indexes with a passage in the gear housing, which sends fluid under pressure to the upper side of the piston. The upper port lines up with a passage supplying pressurized fluid to the lower side of the piston.
Under that setup, Luke, when the steering valve is in neutral, fluid is directed through both ports equally. That keeps the piston in hydraulic balance.
Okay, I catch. Now, what happens on a turn?
Well, on a left turn, the steering valve pivot lever moves the steering valve down. This opens the lower port wider and closes the upper port to pressurize fluid coming in around the valve. Fluid through the lower port pours into the pressure chamber above the piston flange. The upper port becomes a return flow port to relieve pressure in the chamber below the piston flange.
I see. On a right turn, then, the steering valve moves up, opening the upper port wider. The lower port is closed off from incoming fluid. Pressure increases below the piston flange, and the lower port becomes a return flow port to relieve pressure above the piston flange.
That's the ticket. So you can understand that when the valve is properly adjusted, there'll be equal pressure on each side of the piston flange, and any movement of the valve will result in an equal amount of assist in either direction.
Proper adjustment means there'll be equal assist. Okay, I got that.
Good. The pressure control valve, incidentally, is also a spool-type valve. Its job is to maintain pressure by metering return flow to the reservoir.
Sort of a back pressure regulator valve?
Yeah, Luke. And you'll see how the whole shooting match works together when we trace hydraulic flow throughout the gear, say on a left turn.
Turning left, all right.
When the steering wheel is turned to the left, the sector shaft tends to hold the piston stationary. Because of this momentary resistance, the worm tries to thread its way out of the piston. This tends to move the worm shaft upward. That worm shaft movement moves the center race, which carries the lower end of the pivot lever with it. So the lever moves the steering valve. This opens the left turn port wider and closes the right turn port to pump pressure. But that port is then open to the return flow passage in the steering valve. Pressurized fluid flows freely into the left turn chamber above the piston. At the same time, pressure is relieved in the right turn chamber below because the right turn port is open. The piston moves down and provides left turn power assist. Notice that a sleeve pressed into the cylinder head provides a passage from the upper pressure chamber to the reaction area above the center race.
What's that do?
That's how pressurized fluid is directed against the upper reaction seal. The reaction seal, in turn, presses against the reaction ring and a compensating washer. In other words, there is spring pressure plus hydraulic pressure resisting movement of the center race. It is this resistance that supplies the feel of the road characteristic.
I see. It's a built-in feel, huh?
Yeah, Luke. Now, if somebody will please turn this record over, we'll explain what takes place on a right turn.
You were going to cover what happens in the reaction area when the car is making a right turn? But the same things that apply on a left turn also cover the right turn, don't they?
No, Luke, not quite. You'll notice that on the lower side of the center race, there's a reaction seal and ring, but there's no compensating washer. As a result, There's more hydraulic force trying to resist center race movement on a left turn than there is on a right turn.
Oh, I suppose there's a good reason for that.
Yep, the entire chamber above the piston flange is pressurized on a left turn. Fluid under pressure also enters between the worm and piston, and it fills the area in the piston at the end of the worm shaft. So, fluid in that area pushes up on the end of the worm, while fluid in the left turn pressure chamber pushes down on the piston. Hydraulic pressure on the compensating washer offsets the pressure on the end of the worm shaft. So the driver feels the same resistance to turning in each direction.
Oh, yeah, I understand that now.
All right, here's something else. Remember that as soon as the driver lets up on steering wheel pressure, the pivot lever returns the steering valve to neutral position. Hydraulic pressure then becomes equal on each side of the piston flange.
Why, sure. Since there's no longer any mechanical force trying to move the center race, the reaction springs, along with hydraulic pressure on the reaction rings, move the center race and pivot lever, and therefore the valve into neutral. I understand that.
Good. Then you'll understand that the gear won't resist return of the front wheels to straight-ahead position. Just as in a manual steering setup, it's front-end geometry that straightens the front wheels after a turn.
That brings up another good point in favor of power steering, Keith. The safety angle.
Oh, yeah, Tech. Glad you mentioned it. If the wheel hits a chuck hole, or if a tire blows out, the shock of the wheel trying to change direction will be transmitted to the worm shaft. That movement moves the steering valve, and pressure immediately goes to one side of the piston to prevent the front wheels from changing course.
You mean power quickly comes to the rescue in any case of severe front wheel shock?
Absolutely, Luke. It's a terrific safety plus for power steering. Now let's look at right turn action. On a right turn, the pivot lever moves the steering valve up. This opens the upper valve port and directs pressure to the area below the piston flange. The lower port is opened for return flow to relieve pressure above the piston flange.
Very clear, Keith. How about service?
Well, you know, the power gear won't work right unless the pump delivers enough pressure. So as a starter, always check fluid level. Then, the drive belt adjustment. If belt tension and fluid level are okay, and there's a lack of assist in both directions, see if the pump is at fault.
And that calls for making pressure tests, huh?
Righto, my boy. Install a 1,500-pound gauge in the pressure line between the pump and gear. Make sure the gauge valve is open, so oil flow to the gear won't be restricted. Also, connect a tachometer to the engine.
Start the engine and let it run until both it and the power steering fluid are at normal operating temperature. Fluid temperature should be about 175 degrees. Engine idle should be set at 475 to 500 RPM. Gradually close the gauge valve. Pressure should rise to between 800 and 950 pounds. Open the valve after making this test. If pressure is less than 800, pump output is too low, and the trouble isn't in the gear. It's either in the flow valve, relief valve, or there's an internal pump leak.
How do I narrow down the right cause?
Well, if your test shows almost no pressure, you'll have to repair or replace the pump, depending on the type of pump. On the other hand, if pressure is slightly below standard, there's a further test you can make. Close the gauge valve and increase engine speed to about 1,000 RPM. If the pump pressure doesn't increase noticeably, the trouble is in the relief valve.
Okay, but suppose that pump pressure's over 800 pounds. That means the pump's okay?
Nope, that doesn't necessarily give the pump a clean bill of health. While your test may show pressure's okay in the shop, out on the road when the car is under load, the pump may not deliver enough volume at low speed.
Tech's right. And remember, it's easier to install another pump for testing purposes than to pull the gear out of the car and disassemble it.
I gotcha. install another pump and try the car on the road first, huh?
Yeah. Then if steering's okay, the condition was in the pump, and you'll have to repair or replace it. If changing the pump didn't correct the trouble, you'll know the gear must come out because of some internal condition that needs correcting. A case of hard steering or lack of assist in both directions could be caused by oil leakage from the left turn to the right turn pressure chamber. Inspect the D-ring on the piston flange first, and if it's damaged, replace it.
If a car has poor returnability in both directions, front-end alignment, low tire pressure, or a bind in steering linkage is more apt to be the cause. But if returnability is poor in only one direction, road test the car for evidence of self-steering. When you find this combination of conditions, a steering valve adjustment is necessary.
Let's suppose the road test showed poor returnability from a right turn. In a case like that, adjust the valve body mounting screws to 7 foot-pounds. That's just enough to let you move the valve body a slight amount. With a hammer, tap lightly on the plug at the upper end of the valve body to move it downward. Then take your hammer and torque wrench along and road test the car.
You might have moved the valve body too far, Luke. If so, you'd have poor returnability on a left turn, and the valve body would have to be tapped lightly upward.
Where do you tap it to move it upward?
On the back pressure valve housing mounting screws. Be very careful that you don't hit the housing. A dent there would interfere with back pressure valve operation.
Okay, I'll watch it. Now, when I get it so returnability is the same in both directions, then what?
Then you've adjusted the steering valve body properly. So, tighten the attaching screws to 15 foot-pounds and you're done.
I see, Tech. I guess I can handle that all right.
Sure you will, Luke. This reference book has more tips on that, along with information on adjusting backlash properly. You'll find it mighty useful.
Swell, Tech. I'll study that book carefully.
Good. Power steering, after all, is becoming a standard item. The more we know about it, the more customers we'll have looking to us for service.